Alright, so this is just a video on molarity in honors chemistry because it was a little confusing for me, and I just wanted to make this video. What the heck was that? But anyway, I wanted to make this video because it was a bit confusing for me, so I just wanted to make it for other people. And on the paper that we got is called Molarity Practice Problems. And there's basically 4 types of problems on that paper, and I'm basically going to go through each one of them step by step. Not through every question, but the 4 types of problems. As we can see, we have the formula for molarity right here. It is molarity, which is M right here, equals the moles over the liters. That's what this division sign is. That's moles over liters. So this first question is quite simple. It says, what is the molarity of a 0.115 liter solution made with 1.25 moles of potassium fluoride? So we already have everything that we need here. So all I need to do is do 1.25 over 0.115, and that will get us an answer of 10.9. This is simple. This is as simple as it's going to get. So that's how you would solve a problem like that. And then going on to our next problem, we have how many liters of 4.00 mole solution can be made using 0.750 moles of lithium bromide. So this is kind of like the last one, but not really. And all I mean by that is all we're looking for is the liters. All we're looking for is the liters. But we already have the molarity, how many liters of a 4.0 mole solution. That's the molarity right here. That's the molarity. And then can be made using 7.50 moles. And we have the moles right here. So this connects to this, and this connects to this. So we can just implement these values into this equation. So we have 4.00 equals 0.750 over liters. And I'm just going to use L for liters. So the way you would solve this is that you just multiply the L to the other side. And so that gets rid of the L as a denominator. So then we would have 4.00 times L equals 0.750 just by itself. And then now we would just divide by 4 so we can isolate the L. And then once you do all of that, you get the answer is 0.188. And I suppose that this would work for any situation like this where you're not given a value for one of these. You would just implement everything into the equation as normal except for the unknown, and then you would just solve. So that's how you would solve an equation like that. Now next up is this problem right here. And this problem, I'm going to be totally honest, I don't know why the equation of how to solve it is written as it is written, but I'm just gonna write down what I wrote down and what was actually on the board in the class, just so you could see how it was written and how to solve it. But I'm just gonna continue. So we have how many grams of potassium carbonate are needed to make 200 milliliters of a 2.50 mole solution. So the way you would solve this, well, first of all, notice that this says 200 milliliters, but the equation needs to be in liters. So 200 milliliters is equal to 0.2 liters. So now we have that. And this is the funky way that you would write this thing, right? So we have the liters times this mole junk equals 1 mole of potassium carbonate over the liters times the liters. I couldn't tell you why it is written like this, but apparently it is. And apparently this is what happens. These two things cross out. And basically, all you're really doing is just multiplying these things together and getting your answer, which when you multiply those together, you get 0.50, and then you just slam this label on it, so you have 0.50 moles of K2CO3 potassium carbonate. And then, since we need the grams, you just do the conversion thing. So you do times, and the molar mass of K2CO3 is 138.2 grams. And then that's over 1 mole of the same thing. And then obviously you know how this thing goes. Actually, let me just write down the whole thing just so you can get the full picture. It's supposed to be a K. That looks like an H. Whatever, it's fine. These two things cross out, and then you can just solve for this thing. And this would equal 69 grams of K2CO3. So that's how you would solve for that. Again, I genuinely could not tell you why it is written like this, but what I do know is that it is correct. So, yeah. And then we have this last problem. It says, what is the concentration of 450.0 milliliters of solution that contains 200.0 grams of iron 2 chloride, which, when it asks what is the concentration, this right here, that just means molarity. That just means molarity. And I'm sure that you'll notice that this is in milliliters, so again, we have to convert, which that would just equal 0.45 though. But 450.0 milliliters is equal to 0.450 liters. So the way that you would solve this problem is we're looking for the molarity, right? And we already have the liters. So now we just need the moles. And we can find the moles by doing our conversion. Because if we have 200 grams of iron 2 chloride, we can convert that to moles. So we have 200.0 grams of iron 2 chloride. And then we just do the mole conversion thing. So we have 1 mole FeCl2. And then we need to put the molar mass, which in this case would be 126.9 grams of FeCl2. So, ding ba dang, these things cross out. And then you're left with an answer of 1.576 moles of iron 2 chloride. And now that we have this, we can just implement this and this into this equation. So we'd have 1.576 over 0.450, and that equals 3.50 molarity, which I'm pretty sure you're right with an italic M. Like, you're supposed to write it with an italic M. So I don't know, but I just write it with an italic M just to be safe. Would basically just write a tilted version of the letter. That's basically the easiest way to do it. But we have 3.50 molarity of FeCl2. And maybe I should have written that for the first equation if I didn't write the italic M, like the first problem we went over, the first problem that we went over. But whatever. This is the answer. So that's how you do all these problems. But with all that being said, I think I touched all bases. So again, if anybody needs help with anything, just leave a comment, leave your name, what you need help with. I'll try to make a video on it. But that's it for this video. That's it. So, peace.